Hey everyone, welcome back to our channel Music and Logic, and I'm excited to have you here as we continue our Python journey. Before we jump into today's topic, let's quickly go over the answers to the MCQs I posted in the last video. I hope you all had a chance to try them out, and these questions were designed to test your understanding of the previous concepts we covered. So let's take a look. The first question is, which function is used to display output in Python? The print function is what we use to display output in Python. It's one of the most commonly used functions as it lets you print anything you want to the console. And which of the following is the most recent method for string formatting in Python? So f-strings are the most modern and efficient way to format strings. F-strings were introduced in Python 3.6. So they allow you to directly embed expressions inside string literals, making them more readable and concise compared to older methods like modulo operator and format function. And what is the result of 10 modulo 3 in Python? And the modulo operator is used for finding the remainder of a division. In this case, 10 divided by 3 gives a remainder of 1. What will be the output of the expression phi equal to 5? This is the equality operator which checks if two values are equal. Since phi is equal to 5, the expression evaluates to true. And what does the logical operator OR do in Python? The OR operator checks if at least one of the conditions provided is true. If even one condition is true, the entire expression returns true. And which operator checks if a value is not present in a sequence? The not in operator is used to check if a value is not present in a list, tuple, string, or any other sequence. If the value is not present, it returns true. I hope you got most of those right. Don't worry if you missed any, the key is to learn from them. Now, with that out of the way, let's get into today's topic, conditionals in Python. So, in today's session, we are diving into one of the most important and foundational concepts in programming, conditionals. Now, conditionals are what give your programs decision making power. Without them, all your code would just execute in a straight line, one step after another, without being able to make any choices. But in the real world, choices are everywhere, and conditionals lets you bring those choices into our code. Let's dive right in. Alright, so what exactly do I mean when I say conditionals? Let's think about a simple real life example. Suppose you're hungry. If you're hungry, you might decide to eat. If you're not, you won't. It's a pretty straightforward decision, right? Well, in Python, conditionals work in a similar way. You write code that checks whether something is true or false. If it's true, you do one thing, and if it's false, you do something else. The most common structure we use for conditionals in Python is the if, ELIF, and else statements. These are super powerful and flexible, and by the end of this lesson, you will see just how much you can do with them. Let's start with the most basic conditional structure, the if statement. This is the simplest form of decision making in Python. You use if to test whether a condition is true. If the condition is true, Python will execute the block of code that follows the if. If it's false, Python just skips it. So let me give you a real life example. Now, if the weather is good, we'll go for a walk. Then we'll have lunch. So, as you can see, having lunch is not a conditional activity and doesn't depend on the weather. And here is an example. Imagine you're creating a program that asks a user for their age and checks if they're eligible to vote. Okay, so first I am going to show you how a basic if statement works. Let's start by asking the user for their age using the input function. So remember, the input function always returns a string. So we need to convert it to an integer. So that is why I am wrapping the input inside the int function. If age is greater than or equals to 18. What this line does is simple. It checks whether the age entered is 18 or above. If it is, we are going to print a message saying you are eligible to vote. So let me run this for you. Now I will enter 20 and there we go. The program prints that I am eligible to vote. Now what if I enter 15? Nothing happens because the condition was false, so Python skipped over the if block. Also, I have attached the flowchart for every statement which gives you better understanding of the syntax. Please pause the video and understand the syntax by looking at the flowchart. So, the else statement is kind of like a fallback plan. So, if the if condition isn't met, or in other words, if it's false, the else block will be executed instead. For example, we started out with a simple phrase which read, if the weather is good, we'll go for a walk. There is not a word about what will happen if the weather is bad. We only know that we won't go outdoors, but what we could do instead is not known. We may want to plan something in case of bad weather too. We can say, for example, if the weather is good, we'll go for a walk, otherwise, we'll go to a theater. Now we know that we'll do if the conditions are met, and know what we'll do if not everything goes our way. In other words, we have a plan B. So Python allows us to express such alternative plans. This is done with the second slightly more complex form of the conditional statement, the if-else statement. Let's modify our voting eligibility program to handle both scenarios, when the user is 18 or older and when they are younger than 18. Alright, but as we saw, nothing happens when the condition is false. To fix that, we can add an else statement. This will allow us to print a message when the condition isn't met. I am going to type in else. Notice how I don't need a condition here. The else block only runs if the if condition is false. Now, if the user's age is less than 18, we'll print something like you're not eligible to vote yet. Let's try this out. I'll enter 16 this time. See, the program now gives feedback even when the condition is false. Now let's take things up a notch. What if we need to check more than two conditions? For instance, let's say we are grading a student's test score. We don't just want to know if they passed or failed, we want to assign a grade like A, B, C, or D depending on their score. This is where ELIF comes into play. ELIF stands for else if, and it lets you test multiple conditions in sequence. Let's see how that works. For example, again, we'll change our plans and express them as follows. If the weather is fine, we'll go for a walk. Otherwise, if we get tickets, we'll go to the theater. Otherwise, if there are free tables at the restaurant, we'll go for lunch. If all else fails, we'll stay home and play chess. Have you noticed how many times we have used the word otherwise? This is the stage where the ELIF keyword plays its role. So let's create a grading system for students based on their marks. I'll start with the basic structure. We'll ask for the user's marks and convert it into an integer. Now I'll check if the marks are 90 or above using if marks greater than or equals to 90. If that condition is true, the student gets an A. Next, we'll use ELIF marks greater than or equals to 75. And here, if the marks are between 75 and 89, the student gets a B grade. And we can keep adding more ELIF conditions like marks greater than or equals to 50 for a C grade, and finally the else block will handle all other cases. Here it will assign a D grade. So now let's run this and check. If I enter 85, the program prints grade B. And if I enter something like 45, we get grade D. Alright, let's take a look at this flowchart which explains the flow of ELIF statement in Python. This is how Python decides which block of code to execute based on a series of conditions. Let's break it down. Firstly, the flow starts with test expression 1. Here Python checks if this condition is true or false. If it's true, the program executes statement 1, and if it's false, we move on to the next test, which is test expression 2. After moving to test expression 2, Python checks this condition. If it evaluates to true, statement 2 gets executed. If it's false, we move to the third condition, which is test expression 3. Now we evaluate test expression 3. If it is true, statement 3 will be executed. If test expression 3 is also false, we move to the else block. Now, if all the test expressions 1, 2 and 3 turn out to be false, the program will execute the code inside the else block. This ensures that something still happens even if none of the conditions are met. Once any of the statements are executed, whether it's statement 1, statement 2, statement 3 or the body of else, the program then proceeds to the statement just below the if else block, which is the next line of code outside the conditional structure. The structure is important because it allows your program to make decisions based on the conditions you set. It's what gives your code the ability to behave differently in different situations. Now that you understand if, elif and else, let's explore a slightly more advanced concept, nested conditionals. Sometimes you will find yourself in situations where you need to check a condition inside another condition. It's like making a decision within a decision. For example, if the weather is fine, we'll check if it's not too hot. If so, we'll go for a walk. Otherwise, we'll stay in the shade. If the weather isn't good, we'll check for theater tickets, and if friends are free, we'll go to the theater. Otherwise, we'll watch a movie at home. If tickets aren't available, we'll check for a restaurant table. If there is one, we'll go for lunch. Otherwise, we'll stay home and play chess. This showcases how nested conditions works, allowing for checks within checks. So, let's create a program that checks if a number is positive, negative or 0. But if it's positive, we'll also check whether it's even or odd. First, I'll get the user input for the number. Then I'll write the outer condition. If num is greater than or equals to 0, which checks if the number is non-negative. Now inside this block, I'm going to check if the number is exactly 0 with if num equals to 0. If it's not 0, we know it's positive. So I'll print that. Outside the first block, we'll add the else to cover the negative numbers. Let's see this in action. I'll enter 0 first. Yeah, it prints the number is 0. Let's try a positive number like 12. It says the number is positive. And if I enter a negative number like -5, we get the number is negative. Next, let's look at this flowchart that explains nested if statements in Python. A nested if statement means an if statement inside another if statement, and it helps you evaluate more than one condition before taking an action. Let's break it down. First, Python evaluates the test expression. If this condition is true, the program moves to the body of if and executes the code there. And if the condition is false, the program skips the main body of the if block and evaluates the next set of conditions. This is where the nested test expression comes in. So if the first test is false, Python checks the nested test expression. If the condition is true, the program will execute the body of nested if. And if it's false, it will execute the code inside the body of nested else. So the else block at the bottom of the structure ensures that something will always execute even if none of the previous conditions from the nested or outer if block are met. No matter whether we follow the path of the main if, nested if, or the else block, the program eventually moves to the statement just below if, continuing with the next piece of logic in your program. This nested if else structure helps in situations where you need to evaluate multiple conditions step by step. It gives your code more flexibility and control when handling complex decisions. Next, let's talk about using logical operators with conditionals. These operators and, or, and not allow you to combine multiple conditions into a single if statement. Let's break them down one by one. Both conditions must be true for the whole expression to be true. This is for logical and only one of the conditions needs to be true for logical or. And not operator simply inverts the result of the condition, making true become false and vice versa. So here is an example of a login system where a user has to provide both a correct username and password. So now let's talk about combining conditions using logical operators. In this example, I'll show you how to use the AND operator to check multiple conditions at once. Let's create a basic login system where a user needs to provide both a correct username and password. I'll start by asking for the username and password. Now I am going to write the condition if username equals to admin and password equals to password123. This checks if both the username is admin and the password is password123. If both are correct, we print login successful. Let's try it out. I'll enter the correct username but a wrong password and it says invalid credentials. Now let's try both correctly. And there we go, we are logged in. And coming back, here are the truth tables of logical operators. Look at the truth tables to understand how logical and, or, and not operators work. Here are some of the common mistakes that we make with conditionals. So first up we have the missing colon error. In Python, a colon is mandatory after certain statements like if, else, elif and loops such as for and while. If you forget to add the colon, Python won't understand where the code block begins and you'll get a syntax error. So let me show you an example. Why does this happen? Because the colon is missing after if x greater than 10. To fix this, all you need to do is add the colon like this. It's a simple fix but very easy to miss. And the second is incorrect indentation. Next, let's talk about indentation errors. Unlike many other programming languages that use curly braces or keywords to define code blocks, Python uses indentation. This means that the amount of space before your code really matters. For example, take this code. Here, Python will throw an indentation error because it expects the print statement to be indented. The correct version should look like this. Now the code is properly aligned and Python knows that the print statement is part of the if block. And lastly, let's discuss about the logical order of conditions in if, elif and else statements. When writing conditional statements, we need to ensure that the conditions are arranged from the most specific to the most general. Here is an example of how things can go wrong. Notice the line elif x greater than 5. This will never run because it's placed after x greater than 3. Since x greater than 3 is a more general condition, the code skips x greater than 5. To fix this, we need to rearrange the conditions in the correct order. Now the conditions make sense and the code will execute correctly based on the value of x. So these are few of the common mistakes that we make with conditionals. Now let's see some of the example use cases. So let's now apply everything we have learned with a simple program to check whether a number is even or odd. We'll use an if-else structure with the modulus operator to determine the result. Let's do a quick example. First, I'll ask the user to input a number. Then we'll use the modulus operator to check if the number is divisible by 2. So if num modulo 2 is equals to 0, the number is even, otherwise it's odd. So after entering the program, let's run this. Now I'll enter 4 and it prints 4 is an even number. What if I enter 7? It says 7 is an odd number. So this is a nice little exercise to see how conditionals work with arithmetic. Alright, let's take another real world example, an age groups classifier. We want to categorize people into different age groups like child, teenager, adult and senior based on their age. So this is where if, elif and else come in handy. I'll start by asking for the user's age. Next, I'll write a series of conditions to classify them into different groups. First, if age is less than 13, we'll print you are a child. Then we'll use ELIF age less than 20 for teenagers and ELIF age less than 60 for adults, and the else block will catch everyone 60 or older. Let's test this out. I'll try 25. It says you are an adult. Now I'll enter 10. It prints you are a child. Finally, let's try 65. And the program says you are a senior. So let's finish with a real world application of conditionals that's super practical, a discount calculator. Imagine you're running an online store and you want to apply different discounts based on the total purchase amount. We'll use if, elif and else to implement this logic. So let's create a discount calculator. This is something you might actually use in an online store to offer discounts based on the purchase amount. So now I'll ask the user for the total purchase amount. Next, I'll use if and elif to apply different discounts. If the purchase is over 1000, we'll give a 20% of discount. And if it's between 500 and 1000, a 10% discount. And finally, if it's less than 500, no discount. Then we calculate the final amount using the discount and print it. Let's try this out with a total purchase of 1200. The final amount after discount is calculated. And yeah, it works. So these are few of the examples which gives you better understanding of the concepts that we have learnt. Alright everyone, that's it for today's lesson on conditionals in Python. As you have seen, if, else and elif are incredibly powerful tools that let you control the flow of your programs. Whether you are building a simple number checking tool or a complex system like a discount calculator, conditionals will help you make decisions in your code. And if you found this tutorial helpful, make sure to like and subscribe to our channel Music and Logic. And don't forget to hit that notification bell so you will never miss an update. In the next video, we'll dive even deeper into loops, a core concept that will take your Python skills to the next level. Until then, keep practicing. And hey, if you ever feel bored or need a quick break, do check out our music shots of Telugu songs to refresh your mind. Thanks for watching and I'll see you in the next video. Now that we have covered the basics of conditionals and some practical examples, it's time to test your understanding. On the next two slides, you will see some MCQ style questions based on everything we have discussed. Take a moment to pause the video, go through each question and see if you can answer them correctly. Ready? Let's go. Here is your set of questions. Pause the video now, Think about each one, and once you have answered, we'll go over them together. I'll see you in the next video. Bye bye.